This video is going to be a brief summary of the scatter error ratio as well as the Clarkson method. Now, the Clarkson method is going to be pretty involved, and I don't want to go through it step by step, but I will give you a general synopsis of what it is because in general, you guys are not going to use this, but you need to know what it is. We have discussed tissue error ratio before. The tissue error ratio, of course, is going to be measuring the dose that is delivered to a certain depth in a phantom at a certain reference field size to what it is in the air. And this concept is going to carry over. And the idea here behind the scatter error ratio is that we can separate the amount of dose that is delivered via the primary beam from that is scattered. And so that's where rather than the TAR, that is where the SAR, or the scatter error ratio, comes from. You're looking at scatter dose that is going to this particular point in relation to what it is in the air. Now, how do you get to that? The scatter error ratio is going to be equal to the tissue error ratio minus the TAR delivered here at the same depth, but with no field size. In other words, it would be just almost a point source is what you would be looking at that's going straight into the patient so that no scatter is involved. So you're taking out the direct part of the beam from all of the dose that is measured there, and that is what's going to give you the scatter. Now, when it comes to the Clarkson method, this is normally used for irregular fields when you're trying to get at what the scatter component is at a particular point within the field. So let's take, we've got a mantle field here where we're trying to hit certain nodal patches and things of that sort. And let's say we are wanting to be able to reach whatever the SAR is here at this particular point. So what we are doing in effect is we are taking this part right here and we're dividing it up into different sectors. You can see here we've got many different lines that are coming out of this. So it is dividing us up into several different lines that are all coming out of the same point. And usually, as is recommended, this is another description of the scatter error ratio. It's pretty much what I had already alluded to. What you're doing is you're dividing the field up into radii of 10 degrees each. And they're radiating out from a central point. The distance along each radius is measured and compared with the table of scatter error ratios for a circular field of that radius. In other words, you got a certain radius here where it goes and it hits the field, and you're trying to determine what those distances are. By summing the scatter error ratios of each radius and then dividing the result by the number of radii, an equivalent field size is generated. This can then be used to adjust the monitor units to accurately estimate what the dose is. So that is essentially what's going on here with the Clarkson method. You're attempting to determine what the scatter component and the primary component are out of an irregular field. So again, here the average TAR is going to be the TAR at a field size of 0 plus the SAR. And again, the TAR with a bar over it is going to be the average. That's what the bar means. It's the average. Average tissue error ratio, the SAR, is going to be the average scatter error ratio. And that is the essence of the method here. Like I said, I won't go into specifically how all of it works, but that is what the Clarkson method is about.